first major problem with Clojure is that it has a horrible notation that it inherits from Lisp, where it uses the parentheses to sequence the operations. And this notation has proven to be unreadable 40 years ago. It was unreadable 30 years ago, 20 years ago, 10 years ago. It's unreadable today. It's going to be unreadable for eternity. And until the Lisp folks just cut it out and fix their notation and just go back and rethink it and say, gosh, we really don't need those stupid parentheses to sequence the computation. Let's rewrite our grammar to make it read left to right, and suddenly the clouds will part, and Clojure and this new version of Lisp will suddenly be the greatest thing since sliced bread. Until they fix it, it's really dead on arrival, in my opinion, because it's just unreadable. The first major problem with Clojure is that it has a horrible notation that it inherits from Lisp, where it uses the parentheses to sequence the operations. And this notation has proven to be unreadable 40 years ago. It was unreadable 30 years ago, 20 years ago, 10 years ago. It's unreadable today. It's going to be unreadable for eternity. And until the Lisp folks just cut it out and fix their notation and just go back and rethink it and say, gosh, we really don't need those stupid parentheses to sequence the computation. Let's rewrite our grammar to make it read left to right, and suddenly the clouds will part, and Clojure and this new version of Lisp will suddenly be the greatest thing since sliced bread. Until they fix it, it's really dead on arrival, in my opinion, because it's just unreadable. I said, unfortunately, people who write Clojure, because it's very experimental language, people are, number one, lazy, and number two, sloppy. And those two are really a fatal blow against the language. I mean, I'm looking here on the screen at some code that is inside Lighttable, which is, the poster child of fantastic Clojure productivity that got so many people excited and went, wow, Lighttable is the wave of the future. And then look at the code inside. They don't have a single line of comment on key sections of their code. Now, how are you supposed to understand that, improve it, maintain it? How is somebody going to understand what this thing does when there's so few comments? I mean, this is the problem with picking a language that encourages the worst kind of hacker behavior, because they don't care about what happens, and this is why Clojure sucks, is that the people in it are this way, and until they change their way and shape up, how are you going to get anywhere? And this is a big one, is that Clojure seems stuck in the 60s with a terminal interface. I mean, when Lisp was started, they had terminals, and they typed in commands to the terminal and it would immediately execute it. And this was considered mind-blowing, because this is from the same time that people had punch cards and would only get 3 runs a day. So this seemed like space age stuff, and so it was a very advanced thing in its day, but it's still stuck there. People are still thrilled to type in a line of code and then see it executed immediately, as if people wrote one line at a time and tinkered with their programs in such a way. I mean, did Tolstoy write one line of War and Peace and then see how it went? He would have never gotten anything out the door. So this is the idea that you're going to write in such tiny increments and then test it is nonsense. That has no productivity to it at all. A good programmer should be able to do, 1,000 lines a day. They should just be able to write fluently as fast as they can type, and then run it and have it almost all work. That's the ideal of a language. Clojure is so tricky that, yeah, people have to tinker with one line at a time because they can't imagine what it's doing. But the biggest problem here is that how are you supposed to do anything practical like an iPhone app or something for the graphically interactive? People aren't on terminals anymore. They're on touchscreen devices. They're either on their cell phone, which is a smartphone, or they're on their PC, or they're on an iPad. There's only three kinds of computers in the world, and the dominant usage has already swung towards mobile devices, iPhone and iPad and so on. And desktops are starting to sink, but for people doing serious work, yes, they still in front of a desktop because, let's face it, they need the big screen. It's preposterous. You're going to run Excel on your cell phone? No, it's crazy. You can't see anything. So, but the problem with Clojure is, how are you supposed to build something that people are going to want when all you're doing is playing with character strings and doing text? I mean, yes, there's a need for batch processing, but if you're going to be just doing character manipulation, why don't you just use Python? It's so much easier to learn and read. The next problem that Clojure has is that it lacks structure. In conventional languages, you write in a more or less hierarchical. Imperative languages, you write in a hierarchical manner, building a tree of functions, and you organize them into sets. It works just fine. And you can build some very big products and still have it be manageable. Clojure becomes messy and ugly very quickly, because the bite-sized pieces that you assemble a Clojure product out of, these very small functions that are typically less than 10 lines. In fact, the Clojure people often have this kind of snotty attitude about how great it is to have short functions, and they say that anyone who writes more than 10 lines of Clojure is a fool, and everything should be very, microscopic pieces. That's kind of like saying, well, I want to build the Taj Mahal, but I only want to do it out of sugar cubes. Wouldn't you want to use a bigger block when you're going to build a big system? Certainly, the complexity goes up, and the number of interconnections and dependencies goes wildly up as you increase the number of pieces. In any system, if you have cross dependencies, the more cross dependencies you have, the more difficult it is to model in your head what the thing is really doing, and it becomes beyond n squared in its combinations, and at that point the large system collapses under its own weight because it becomes unmaintainable. We've already seen that the conventional languages become unstable and unworkable above 1,000,000 lines of code, because pretty much every product above 1,000,000 lines never finishes, ever. It never goes to zero bugs. It just keeps floundering around. Microsoft and Apple both have more than 100,000 outstanding bugs in their bug database that they're never going to fix because they can't reproduce them. They don't have the manpower. They're only going the high priority ones. It takes Apple 4 releases every time they release a new operating system before they achieve stability. They're on 10.10.3 now. That's their 4th release. The first 3 were garbage. They were full of bugs. They crashed. They hung. They did all sorts of things wrong. It often takes them 6 months after a release to get it finally stabilized, and that's because the product is so big. The thing is that Clojure doesn't look like it scales up well at all, because products, even small products like Lighttable, are becoming frozen in time because it's extremely difficult to figure out how to improve it, because you can't understand the small code base that it is now. It's not even 10,000 lines, and it's already unmaintainable and unknowable and mysterious. And products should be able to reach very large sizes. A good language will let you write a complex program in a systematic and orderly way. If you compare Modula 2 or Pascal, but just say Modula 2 versus last, good version of Pascal, it beats the pants off of Clojure in terms of clarity, reliability. Hardly anyone is using Modula 2, but that popularity is not an indicator of quality. There are plenty of things that are popular that suck. Clojure doesn't address the big problems that are facing computer programming today: reliability, maintainability, and variety. You need a system, a programming language where you can write code and absolutely know that it's going to work. There's a lot of academic research on systems to, different techniques for writing programs that are guaranteed to work. That you write the code out, the compiler checks it, and it says, okay, your code is going to work exactly as you intended, and there will be no errors of any nature, of any significance. And they have built little demonstration systems that do this. Now, the next thing is maintainability. To be a practical language, we've got millions of programmers around the world. You're going to work on a product for a while, you're going to lose interest on it, you're going to go on to something else, you're going to give the code to somebody else. Computer software lasts 20-25 years, easy. I mean, there's people, companies like Chase. I went in and got my mortgage redone, and the guy was taking an awful long time to type it into the system, and I said, gee, what kind of computer program you got? And he turned around the screen, he said, you won't believe it, and there he was running a DOS emulator on his PC, that was running or a mainframe terminal emulator. Anyway, it was unbelievable. It was at least 25 years old, this mortgage system that Chase is still using. But it's maintainable, so they're using it. Variety. You need to be able to write many kinds of programs in a programming language. And in this sense, I think Python beats the pants off of Clojure, because Python can do so many kinds of programs. You need to do text manipulation, you need to do manipulating log files, you need to do HTML processing. There's so many things that Python does well, and if you invest in Python, you'll be able to use it more frequently. Clojure does not have very good variety. The fact that it can't draw on the screen, doesn't have an event model, doesn't have this concept of a timer and a frame rate. I mean, how are you going to make Pac-Man or a Pong in Clojure? I mean, I suppose there are people probably who have done some games in Clojure, but by no means was it facilitated by the language itself. And that is why I come to after studying Clojure, I really think it's a dead end for computer programming. The technical evolution of languages will continue, and Clojure will not make it into the final round.